So in this example, we start out with a fixed volume container, and it contains 1 mole of component A, and its pressure is 1.9 bar. And the saturation pressure of A is given as 2 bar, which means since the pressure is less than saturation pressure, we have all gas when we start out. Now we add 1 mole, the same container, the volume doesn't change. We add 1 mole of component B. So we have a mole of A and a mole of B. And now the pressure is 1.44 bar, which means some of the A must have condensed, and of course some of the B must also condense. And so we have a vapor-liquid mixture, and it wants to determine the phases, which is vapor and liquid, and we want to determine their composition, ideal gases and ideal solutions. So this means Raoult's law, which means the pressure, which is 1.44 bar, is going to equal the mole fraction component A times its saturation pressure plus the mole fraction of B times its saturation pressure. So let me substitute those values in. Here you've noticed I've substituted for XB in terms of XA. And so now I have an equation I can just solve for XA. I can simplify to 2 minus 1 times XA plus 1. So XA is 0.44. And so that's one of the compositions. That's the liquid phase composition. That means we can calculate YA from Raoult's law as XA PA sat over P. Pause and substitute those numbers. So I have the gas phase mole fraction, I have the liquid phase mole fraction. It asks to determine the number of moles of these phases, and so that requires a mass balance. And I'll write a mass balance for component A. So number of moles in the liquid phase of A is the mole fraction times the number of moles of the liquid. Number of moles of A vapor phase is mole fraction of A times the moles of vapor, and then ZA then is the overall mole fraction of A in our system times the total number of moles. So what we're going to do, ZA of course is we have 1 mole of A and 1 mole of B, so ZA is 0.5. We know XA and YA. Liquid plus vapor adds up to total number of moles, and total number of moles is 2 moles. So this number here, this is 2. And we'll make the substitution that then the solve for L, so V is the number of moles in the vapor phase, so 2 minus the number of moles in liquid phase is the number of moles in the vapor phase. So now if I substitute the numbers into this equation, I have the mole fraction in liquid phase that I calculate, L is my unknown, the mole fraction in the vapor phase that I calculated, and V is 2 minus L, this is 0.5 and this is 2, so that means we have of course total 1 mole of A, and we can solve for L. And when we do that, L is equal to 1.29 moles. So that means V is equal to 0.71 moles since we have a total of 2 moles in our system. So here's L, here's V. That's the last part that we had to calculate in this example.